Guys are on mute because we're just waiting for everyone to join and then we'll start, inshallah. Okay, guys, we are going to start because many people have joined. Okay. Hello, everyone. So my name is Aisha.
And my name is Aizah.
And today we're going to talk about data communication. We're going to be looking at different topics. We're going to be looking at what is data networking. We're going to be looking at different networking devices. Aizah will be explaining that. We'll be looking at switches, firewall, routers. We'll be looking at end and intermediate devices. We'll have some quizzes on the way. We'll also look at the OSI model or the IP address. Now, you guys have the option if you guys want to choose, if you guys want us to, teach you guys the OSI model or the IP address.
Now guys, going over a few house rules. So this lecture will be about 90 minutes long, and after 45 minutes you guys will be having a 5 minutes break to regain your energy. And if you guys need to talk about anything and if you guys have any questions, you guys may raise your hand or write your question in the chat. So what is data networking and why is it so essential? So what data networking basically is, it's basically literally the process of connecting two or more devices with each other. What this does, this allows the devices to share information and resources. You can imagine it like this. A group of computers are linked together, allowing users to send emails, browse the internet, or access shared files and printers. I only listed a few of the things it can do, but it can do also many more. So basically, without data networking, the internet that we rely on wouldn't function. So data networking is like the backbone of communication.
The thing is, we did forget to do our introduction. My name is Aisha, and for the past 4 to 5 years, I have been enhancing my technology skills. I've done lots of courses. I've done graphic designing. I've done web development, and in web development, I've done many other separate courses, such as I've done React.js, I've done JavaScript, I've done advanced JavaScript, and I've done many other different courses throughout the years. And I've also been learning CCNA. I've been learning from Sir Imtiaz. He's a very nice teacher. I'll tell you guys about the teachers a little bit on the next slide.
Okay, so my name is Aizah Khan. I am a 12-year-old girl who has been doing IT for about the past 3 years. And I'm so looking forward to enhancing my IT skills, and I can't wait to be on this journey with you guys. And underneath, I also listed a few of the courses I've done.
I did tell you guys that we will talk about the teachers. So I would like to express my heartfelt gratitude to these teachers. Because of them, we have improved on CCNA so much. This is Kaur Butt. Okay, Sir Kaur Butt. And we have done a boot camp for 40 hours. It was late in the night and it was a bit of a, pain. And we did have testing and we had marking and everything because we still do go to school. And we have also learned from Sir Imtiaz. We've learned from him for 4 months. And we had, these two teachers helped us so much in our CCNA journey. Big thanks to Sir Imtiaz because he's the one who taught us different concepts. Now, Aizah has already explained what networking is, but she hasn't really expanded on data. Now, data is the raw information that is stored, and it can it's any information. For example, it could be videos, it could be photos, it can be audio, it's like raw information, okay? Now, the data has 3 different states. So now you guys, this is not really written in the slides, but I'm going to explain this. Now, 3 different states are, one of them is data in rest. Right now, you have joined in Zoom, okay? You have joined in Zoom and you still have your files, all your files. For us, we have our homework and everything else, but for you guys, it might be CVs, it might be your cover letters, your resumes, or anything like that. Now, all your data is still stored in there. You have joined this meeting, but all your data is still there, right? That is a type of data in rest. Now, what about the 2 other states? I did mention 3 states, right? The other state is data in motion. Now, data in motion is when data is traveling across different networks. Now, what about the last state? That's data in use. Right now, when you have connected, okay, you have connected to this Zoom meeting, right? Now, your computer is producing you these pixels, these red, see all these different colors that you are seeing and you're hearing my voice. That is some type of data that you are receiving, okay? That's another example of data in use. So 3 states are data in use, data in rest, okay, and data in motion. So that's a bit about data itself and the couple of different states. Now you guys do know what networking is. Networking is when 2 or more PCs, are connected together. Now let's look at this slide. I want to quickly turn annotation on. Okay. By the way, I'm going to explain what these buildings are and why I have added them. So this is the Rio Tinto building. Okay, this building is located in Western Australia. This building is the Spark building and it is located in Auckland, New Zealand. This building over here, as you can see, is the Etisalat building and it is located in United Arab Emirates. Okay, and now it's a bit funny because I was born in United Arab Emirates and I've lived in New Zealand for 7 years, and also for the past 2 to 3 years I have lived in Australia. So I do have a weird connection with all 3 of these buildings in a way. Anyways, now when you look at a building, it is not I know it's really tall and very beautiful and everything, but it's not about the designs. It's about what's inside them. Now these buildings have so many different data networking devices. They have so much going on. Have you ever thought about how, let's say this is floor 30. How is floor 30 sending a message to someone on floor 1? How are they doing that? How is the data traveling from all those different floors? Or for example, this colleague over here, okay, this person from Rio Tinto is sending a message to someone in Spark. How is that happening? How is the data traveling? Now we are going to explain that in this lecture, okay, in this webinar. Now I'm going to explain this using a diagram real quick. I did make a slide for this, but I want to just explain it using this diagram. Now it's going to be a bit sloppy, but let's just do this. Okay, here, imagine this. Okay, let's say this is a building. Let's say this is a Rio Tinto building. Okay, by the way, I have my computer over here, which is why I'm looking at the computer from here, and my camera's over here. Okay, anyways, now hold on, let me add some people. Okay, so let's say these are different floors. Okay, we have a couple of different floors, and this is floor 4, 5, 6, 7, and this is floor 7. Okay, now I want to communicate to a colleague. Let's say I'm in floor 4. By the way, you guys could use any building example. This is a very simple infrastructure, obviously, because there are obviously more floors. Now I'm in this floor over here, floor 4, and I want to communicate to my colleague that's in floor 7. Okay, or let's say I want to talk and I want to go to the internet. How am I going to do that? You might be thinking. Now the thing is, first of all, I'm just going to tell you guys, let's say there are 100 people on this floor. Okay, 100 people. Okay, now I cannot, without any particular device, my computer cannot directly connect to anyone else on different floors, which is why we need different devices. Okay, now for connecting and host, we are going to be using a device called a edge switch. Okay, I want to write that over here, edge switch. Okay, now this edge switch connects to end users, it connects to end host. But the thing is, it does connect to edge switch, the edge switch does connect to end host, right? It connects to me, it connects to other different PCs, it connects to all the different 100 people on that floor. By the way, do keep in mind, there are many different edge switches that are working together in a floor, okay? And the thing that I'm going to explain to you right now works on every single floor, okay? Now, this edge switch is now connected to these end users, but it cannot still connect to the internet, and it can still not communicate with someone on floor 7, which is why another device comes into play. Now that device is known as a intermediate device. Okay, I'm gonna write that over here, intermediate switch. Now, there's 2 types of switch. This switch is connecting to end users, and this switch will connect to another device so that we can go to the internet, or so that my message can reach my colleague, okay? Now, an intermediate, as I told you guys before, let me just go through this again. An edge switch connects to end host, right? End users, okay? Such as a PC or anything else. Now, an end switch needs to connect to another device known as a intermediate switch. And this intermediate switch will connect to a device called a router. Okay, Now this router connects to the internet and it allows you to communicate with different networks, okay? Now let's go through this again. We got the edge switch, it connects to end host, okay? Then it needs the device to connect to the router so we can connect to the internet. I'm gonna make this this is the cloud, okay, also known as the internet. Okay, now my friend can get my message. Okay, now I'm gonna give you guys an example. For example, I'm asking my colleague in floor 7, okay, I'm just saying, are you coming to work today or anything else? Okay, or my message is gonna go as a frame. Okay, it's gonna go to the intermediate switch as a frame, and then when it goes to the router, because the router works at a network layer, it will then transform it into a packet, and then it will finally go to the cloud, to the internet. Okay, now by the way, an intermediate switch and a router, I have put them in different floors, but they do normally work in a main control room. Okay, and by the way, this whole network topology, it comes into a local area network. Okay, local area network. And a local area network is when there's a small network, okay, that comes into play. Okay, and this network is usually used in schools, buildings, your home. It's like basically where there's a small network. Okay, now what about, let's say I'm texting my friend and she lives in New Zealand. I do still have some friends that live in New Zealand. Okay, now to text them is gonna, my data is gonna travel through thousands of different miles. Okay, now that's gonna go through wide area network. I'm not going to explain these two too much, but I just want you guys to have an idea. Okay, so let me go to the next slide. This, oh my, some people have joined. Let me admit them. Okay, no, the other charger. Okay. Anyways, right now we have just discussed about two different switches. We have discussed about the router. The router is used to connect to different networks. Okay, and I have also explained the MCR a little bit. When a very small hint about a LAN and WAN. Okay, but because you guys are beginners, you guys don't need to know this too much.
So guys, networking devices is also one of my favorite topics, and behind I'm not sure if you guys can see, like, there's these symbols. Can you guys see these symbols behind? I didn't put this for decoration, but they actually mean something. So each symbol represents a networking device, okay? And the reason why I'm saying this, because each time you see these, it's not necessary that it will always have the name underneath it. So that's why it will also have the symbol, and you should be able to recognize it by the symbol.
I'll go next. I'll do it.
Okay, so talking about a switch. Switches, so why do we use a switch? On a switch, actually, can you guys see this little gray box over here? This is how a switch looks like in real life. And all of the end devices is a fancy name for saying, instead of, you know how you have to say laptop, mobile, phone, instead of wasting your breath, you can just say end device. That just covers all of the devices.
We will cover this later, by the way, in more depth.
Yeah. So all of the end devices are connected to the switch. And can you guys see those black holes on this switch? Yeah, so what are these black holes and what are they used for? So actually, when an end device is connected to this black hole, which is called a port, so we call these ports. So these will be connected to, the end devices are connected through with a physical cable that connects to the switch.
For example, an Ethernet cable.
So and it's not, the reason why it's not connected to a router but a switch is because the switch is used in a LAN that Aisha explained to you a bit locally, and then the switch will be connected to a router.
Yeah.
Okay guys, so talking about firewall. Firewall is, I don't know why, but it is my favorite networking device because it's so easy to explain too. So a firewall is like a shield. So a firewall, if there's a hacker or a person who is unauthorized and trying to steal your data, what the firewall does, it like blocks them off. So it drops them, like it drops a packet. So the data transfers in packets, and what the firewall will do, with the unauthorized packet, it will just drop it. It will say, sorry, you're not allowed, you're unauthorized. So it doesn't steal your sensitive data in your device. So moving on to a router. A router is used in a wide area network. And like I said about the switches the switches aren't allowed in the wide area, right? So how can they go to the other network? How can they connect? So the router connects one network to another network. So there's like, first there's the end device, then there's a switch, then if you want security, there's a firewall, then there's a router, then that connects to the other part of the network, to the cloud, then the other part of the network.
Now, this is a bit of a repetition. We have already talked about switches. We have already talked about routers. We have talked about firewalls. We haven't really talked about wireless controllers, but they actually manage Wi-Fi connections. But we're not going to talk about these today. For example, we're not going to talk about wireless controllers. We're not going to mainly talk about access points. We are going to focus on switches, routers, and firewalls. Okay? We have already talked about this, so which is why I'm going to skip it.
So guys, we have differences. So there you can achieve a certification. There's these certifications. You don't need to do it, but it's valued in IT, and it could lead to jobs like network administrator, IT support specialist, and network engineer. There are more, but if you guys want to achieve the certification, this would really help. Plus routers, how we talked about routers and switches, they are also made by Cisco. The Cisco is a pioneer, except it is also made by other companies like we have Dell Technologies, Juniper, but Cisco is a pioneer, so it's the most recommended one. And we have three levels. There's the associate level, the professional level, and the expert level. The reason why I'm not saying specialist level is because the specialist level basically comes into the associate level. I have a quiz for you guys, so I hope you're paying attention, and let's see if you guys can answer this quiz. So which certification is the hardest to achieve? I didn't tell you guys what this is, but I want to see if you guys can actually do it. Everyone, write your answer in the comments right now. Which certification is the hardest one to achieve? The associate level, professional level, or expert level? Okay, everyone, write your answers.
This is a true question, by the way. Okay. So,
okay, we'll give it 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Only one person got it correct.
One person got the answer correct, and the answer is the associate level. So how is it the associate level? And let me just clarify one thing. The associate level does not mean the hardest level. But how is the associate one the hardest? Like, isn't that the easiest? Then there's professional, then there's expert. So how? Actually, this is how it is. I actually want to also give you guys an example. So when you guys are making so like over here, the reason why the associate level is the hardest one, because you have no background information. Okay, you have literally nothing. You're starting from
building
scratch.
all the concepts.
Yeah, you have to build the knowledge. But what the professional level is, you take that knowledge that you learned and you like make that a bit harder. So it's a bit harder.
It's the same thing but in more depth.
Yeah, so it's like it's like making a sandwich. You have a sandwich, right? But you have to first like make the sandwich and put in the stuffing all by yourself. But then on the if you want to level up the sandwich, you just put another thing on top. You can add like, for example, cheese, and an expert level you could add toppings. This is a very funny example I thought of, but yeah, I hope you guys understood this.
But guys, technically you guys were correct. Okay, but in CCNP obviously is correct. But the thing is, CCNA, you have to build your concepts. And building your concept is the most hardest thing to do, because once you build those concepts, you just have to expand on those concepts for the other certifications. What are end devices? Now, I have talked about end devices a little bit, and Aizah did too, right?
Yeah.
Now, end devices are basically the devices that cannot connect to any other device. They're known as end hosts. The device you are using right now is classified as an end device. Let's say some of you guys are joining from the phone, some of you guys are joining from the laptop. So it's basically all the devices that cannot connect with each other. Yes, in a way, you guys might be thinking, well, I can text my friend on my phone and then they can reply. So what do you mean? Well, the thing is, they use different data networking devices to connect to. If we talk just about them, right? They cannot directly connect with their friends, or we cannot directly text. I cannot directly text my friend without these devices, okay? So an end device, examples are, we have a computer, mobile devices, printers, and smart TVs.
What are intermediate devices? So what intermediate devices are, they're basically firewalls, routers, and switches. And over here we talked about these already.
We have some diagrams on the sides. So as you can see, we have the firewall over here. By the way, the firewall is like a police officer in a way. They just manage and they just look at, oh, are you allowed to come in? No, yes.
Yeah, okay. They'll catch bad guys on the way out.
Yeah, basically. Those bad guys, in technical terms, are basically hackers. Because they don't want your network to get any virus or anything like that. So an intermediate device, by the way, they connect and host. So as I've told you guys before, a network is built of intermediate and end devices. I'll quickly draw it over here. Now let's say I have my router, okay? A router is a type of intermediate device, and a router connects to a switch, okay? A router connects to a switch, and that switch connects to end host, okay? Now that switch connects to end host, also known as end devices. Now these end devices are important because we want to communicate with everyone, right? But in order to communicate, we need different data networking devices such as a switch. A switch is going to help us connect with the router, and a switch then thereby gives our information, everything else to the router, and then the router finally provides us to the cloud, also known as the internet, so that we can text and everything.
Okay, so now guys, we're going to be looking at two roles that classify you. We're going to look at two roles that classify you into different jobs.
Now we got system administrator and network administrator. So system administrator, guess what it manages? You guys can read it over here too. Now, system administrator manages the computer. It manages end devices like computers, like servers, and all those other stuff. And it does more of the maintenance work. It's a bit boring, to be honest. And CCNA, I was gonna spoil a question for you guys. We do have a bit of a quiz. So guys, do look into this a little bit. I will explain it right now. There's a question coming up about...
So do pay attention.
Yeah, there's a question that's gonna come up. Which one does CCNA come into? Anyways, as I was saying, system administrator, it basically manages end devices, okay, and it basically maintains it. And for some other jobs are, for example, there's an error and you cannot connect to Google. A system administrator will help you with that. That's a very basic example. Now remember, these roles are extremely complex. They're more complex than what we're saying, right? But I need you guys to understand these examples are given to you because you guys need to build a concept, and from that concept, when you guys build that concept, then you guys could further on explore and you guys could look at the different roles in more detail. Now let's look at network administrator. A network administrator, if you guys haven't guessed already, if I just said that system administrator manages end devices, a network administrator manages intermediate devices. And those intermediate devices will be, let's say, a switch, we have a router, a firewall. Remember the police officer example that I had given? Now, for this, it actually configures a router. How do you think a router is working and it's working and the data is traveling from different networks? It's obviously going to be configured. Configured by that, I basically mean we're giving it a set of rules, okay, and regulations so that it can work. And we have different, there are also other examples. For example, we're going to set up the switches so they can connect to multiple devices. Now you guys do have a 5-minute break because this it's been 45 minutes.
Since it's quite long, the slides, you guys will be receiving a 5-minute break right now. You guys can freshen up, drink some water, and do what you want, and just come back in about 5 minutes.
And we will have a quiz right after this.
Yeah.
Okay, let's continue.
Be having a little challenge, okay? So we have 4 options over here, and the question is, which of the 4 roles does data networking CCNA fall in? So if you guys were paying attention, and hopefully you all were, and write your answers in the comment section right now, which one you think is the answer.
Okay, some of you guys are applying directly and you guys are correct. Okay. Wait 30 seconds and then we'll start. D.
And remember, guys, we just studied about this, so I want to see if you guys are paying attention.
Okay, so we got like some mixed answers. I didn't really see. Okay, I want to reveal the answer right now. So first of all, I'm going to click on each one and then you guys will see the answer. I want to click on the wrong ones, maybe the correct ones. I don't know. You guys will find out. Now, many of you guys did say D. Now, guys, we just discussed about network administrator. And we did discuss about system administrator. And we did tell you guys that system administrator was when, you know, they manage intermediate end devices, and a network administrator is when they manage intermediate devices. We didn't really talk about a cybersecurity specialist and the other role, which is why this wasn't an answer. We just put this in. So many of you guys did answer A and D, and let's look at D. I'm not going to press C and B because you guys didn't really write that in.
So A is the correct answer.
Because we're going to be focusing on intermediate devices such as a switch, a router, and a firewall.
And did you guys know that you guys are actually becoming a network administrator right now? And A is the correct answer, and it is not D, unfortunately.
Now, if you guys remember in the second slide, in the table of contents, I did say you guys will have the option. If you guys want to choose for us to teach you guys the OSI model or the IP address, you guys have the option for which one we want to teach you guys. Okay, so just tell us in the chat below. Just you guys can reply privately, doesn't really matter. Just tell us, so I'll quickly give you a bit of a demo what's going to happen. In the OSI model, we're going to look at the seven different layers because there's 7 different slides. Okay, and for the IP address, we're going to play a game. Aizah, stop. Okay, and we're going to have some winners and awards like trophies and like, a bit of a certificate. So, and we'll also be looking at binary and IP addressing. So you guys can choose.
Pick IP.
Aizah. I see many people picking IP address. I wonder why. Okay, let's start. So we will go on forward with the IP address. By the way, we did prepare these slides for the OSI model. If you guys want to go to the recording and you guys could take a screenshot later on. So let me just skip all these slides and go to IP address. Now let's look at internet protocol. I will explain these slides, but I might let Aizah do a couple. Okay, now before we look at internet protocol, I want you guys to understand that an IP address is a unique identifier that is used that is assigned to every single device. Okay, now using that bit of information that I have given to you guys, let's look at this scenario. Now let's say you live in house 14 in Buckland Street, Auckland, New Zealand. Okay, and this is the house 14, by the way. Okay, now you live in this house over here. This is house 15, this is house 16, this is house 17. Now you invite your friends over for dinner, but the problem is your friends don't know where to go because in this scenario there are no address names on the houses. Now your friends are confused. Some are thinking that, you know what, they're in the wrong street. Some are thinking that it's the opposite house, and it's like pure chaos. Now because of this, address names were created and assigned to different houses. Now let's look at this scenario again. But this time we do have address names. Now, you live in house 14, you invite your friends over for dinner. Now, thanks to houses and addresses, it's easier for them to identify where you live. Now, look, all of them are going to your house and then they're bringing gifts and everything else. So, what I'm trying to say here is addresses are important so that they can identify where you live, okay? So, for example, let's look at this example over here. Let's say that there's like a postman. Let's say you're doing online shopping and you buy something from Amazon. Now, the guy who is delivering the post to you, for example, it reached Australia and everything, and they have to deliver the mail. Now, they're a bit confused because they don't know which one's your house. Now, they're looking over and over again, but they really can't find your house because there's no addresses. Now, if we look at this example again, and let's say they are address names, obviously it'd be easier for him to find your address. Now, the postman identifies your house by its address. Now, without an address, delivering your items would be much more difficult. Let's say his job is to take 100 mails and like deliver them in one day. It would take him 2 to 3 hours finding one house every single day. Like, and if you times that by 100, that's like 100 hours. It would take her a long time to find your address. Now we're going to look at this, but with devices. Okay, let me just put this down. Okay. Now I want to explain to you which one's me. Let's say this is me. Okay. I'm going to use this as an example. I'm texting my friend. Okay. Now my friend receives a notification. But have you guys ever thought about how the data is traveling from one place to another? Now the thing is, similarly to the house and like the other stuff, the house, for example, the house thing, you guys need an address so you can find your friends and everything else, so you can go and you can have dinner at your friend's house. Okay, and the postman needs your address so they can identify where you live, and so they can go to you, right? Now the thing is, if there weren't addresses, IP addresses specifically, okay, on your phones and in each and every device, it would be much harder for the internet to identify who you are and send your message to your friend. An IP address is in this format. There's 4 dots. Okay, I'll explain the format later on in the next slide. So there's 4 dots that are there are 4 numbers that are divided by dots. Okay, and this is a unique identifier that represents who you are. Okay, it's a unique identifier that it represents you, your device. And this is extremely important. For example, let's say there's a hacker around town and the police are trying to find this person. They will obviously, de-hack them or something, and they will try to find the hacker's IP address, their address, so they can go to him or her. This is basically the same thing. I will just read a couple of lines, okay? But it's the same thing. Now, why do computers need addresses? Now, just like houses, devices also need addresses so they can be identified. Now, for example, when you're texting your friend on WhatsApp or anything else, your data is traveling from your house, is going from your router to their router, and then from their router, then obviously it will go to them, their switch and everything else. Now, that's how the data is traveling. We have talked about how the data travels on the other slides, so we're not going to discuss this further on. Now, I did explain IP addressing with some scenarios, like for example, the postman, we got the houses, okay, we got your friend texting you. But what about the IP addressing definition itself? Now, an IP address is like your device's home address on the internet. It's an address that defines who you are, basically. Now, each and every device has an IP address, by the way. And the thing is, an IP address was created because for example, they're like on the internet, there are 4 billion people on the internet today. Yes, there are 8 billion people in the world, but around 4 billion to 6 billion people use the internet today. Now, because there's so many people, how do you think for example, you're sending your friend a message, how do you think it's going exactly to them instead of your teacher? Now, the thing is, this is all because of IP addressing, because each phone, each device, each laptop, they have been assigned an address known as an IP address, Internet Protocol address. Now, we will look at the different classes right now. Now let's look at the IP address format. Now, as I've told you guys before, the format is pretty simple. There's 4 numbers that are divided by dots. 4 dots. My bad, 3 dots. Okay, and these are classified as an octet. Now, before I go into that, I just want to tell you guys something. Now, there are 2 types of IP addresses. There's IPv4 address, which is used 60 to 80% in the world. And there's IPv6 address, which is more advanced. It's more longer. We will not talk about it today. And it is used about 20 to 40% in the world today, okay? It's a bit more advanced, but mostly the world is using IPv4 addresses. And it's this format, as I've said before. We got 4 numbers divided by 3 dots. I know this is a bit dry, but we do have a game coming up, okay? Now, and it is an IT related game. It's not like any other game, by the way. Now, as I told you guys before numerous times, an IP address is a unique number that identifies who you are. So we're going to skip this right now and let's look at the classes. This might be a bit confusing, okay? I know it is confusing. First, we got the IP address and then we got this, and then we got classes. But bear with me. You guys don't have to memorize all the classes in one day, obviously, but I'm just going to explain to you what these are. By the way, Class A and Class C are mainly used. Now, Class A is used for buildings for larger networks. Okay, it's used for people who need lots of, like, for example, you have so many people in a building, you have 16,000, 60,000. You will use a Class A address. Remember, it's the same thing. We got this, but instead, the number will be from this range. Okay, it's something like that. Anyways, and Class B is used for medium-sized networks. Now, it's not going to be used for homes, that's Class C, but it's used for universities, something smaller than a big company or building. Now, Class C is used for small networks, okay, and there, for example, your home, let's say you open a small business, but what if I have a small business and then it becomes a large business, a very, very large business, okay, then I have a whole building. Obviously, then I'll change to a Class A network. And then IP address classes help us group networks by size because IP address consumption was a very big issue back then. They found that when they created IP addresses, IP address consumption was a big issue because there's so many people that are using the internet and everyone's using Class A addresses and everything else because the range is from 0 to 255. And by the way, if one person uses it, they can get 16 million addresses. That was like the main issue. And then they divided everything into these classes so that there's less IP addresses getting used. Now let's look at what is binary. By the way, we as humans, we understand alphabets and numerical code. By numerical code, I basically mean numbers and alphabets, okay? Now that's what we understand. Does the computer understand something else? Yes, it does. The computers process data using ones and zeros. That's how they understand what we say. For example, I'm sending a message to my friend. Yes, I keep using that example, but it's a simple example. I'm sending a message to my friend. I'm like, hey, are you coming to school today? And that message will, in the backend side, that message will, the computer will convert that message so the computer understands. So that I can display the message in obviously alphabetical code, but it's for the computer to understand, it's going to process the data in ones and zeros. Now, this is also, like, by the way, guys, an IP address is typically written in 4 sets, as I've told you guys before, and it's something like this. By the way, this is a Class C range, and the computers convert it to a 32-bit binary format. So in each of these octets, so these are called octets, okay? In each of these octets, there are 4 octets in a IP address, and in each of these octets, they are, I know this is a bit confusing, we call octets, okay, and everything else, but in each of these octets, they are 8 bits. And 8 times 4 is 32, so that's why we have there's a 32-bit format. And in those 8 bits, this is what's happening, okay? I will give you guys an example. This might be a bit confusing because I'm not really explaining to you guys live, if that makes sense. I'm not showing you how I'm going to convert it, which is why we have created some slides where I am going to convert it and Aizah will play a game of conversion. Okay, I might have spoiled the game for you guys. Anyway, it's actually pretty easy. The game's simple. Okay, and I'm going to quickly skip to the next slide so I can explain what I mean by binary a bit more. This is another example. Remember, it's divided in 4 parts. It's called, and each of the 4 parts are called octets. And you remember, in IP address, they are 32 bits, and in IPv6 address, there are 128 bits. But just, you guys don't really need to know that right now. Just focus on IPv4 addresses. By the way, the whole thing that I'm explaining, everything else, is about IPv4 addresses, okay? Now, in each of these, in each of the octets, in each of the 4 octets, okay, they have 8 bits. Now, this is a bit of an example. And for this thing, you guys might not understand what I'm doing over here and why they're different numbers, but we're going to do conversion real quickly. Now, I want to give you guys this example. I will do this one. Let me just put this down. Okay, put my cursor down. Okay, you can do the next one. So right now we have this IP address and we're going to convert this into binary so the computer understands. Now I need you guys to really focus because you guys are going to do this yourselves. Now it's actually very simple. All you need to do is you need to add, okay? For example, we got 128 and 64. I'm going to put 1, okay? And I'm going to do 1, okay? And then I'm going to add them together, okay? Now I need you guys to help me out, okay? I do know the answer for this one, but obviously, I need you guys to tell me. Does 128 and 64, what is it equal to? By the way, shout out to my friend for coming and joining. Her name is Michelle. Okay, anyways, now let's see. Yes, you're correct. 192. Okay. Someone did message me. I'm not gonna say who. Anyways, that's 192. So yes, you've got 190. By the way, for binary, this is 1 1, and the other ones are gonna be 0. So this one's on. This is the network portion. The network portion is on. The host portion is down. So you basically just add it. For example, we got 128, 64, boom, 192. The other ones are gonna be 0. I'm gonna write it in text format, by the way, like over here. 19. Okay, we got 1 1 0. Remember, there are 8 bits, so obviously we have 8 different numbers over here. 1 1 1 2 3 4 5 6 7 8. I think that's 8. Okay, now let's continue on forward. Let's look at the other ones. Now we got 32. 32 is pretty simple. We got 32 right over here. Okay, and then we put the zeros. The other ones.
Make sure you do add the zeros.
Yeah, like you're supposed to put the zeros in.
What is the binary number?
7, 8.
Someone ask something.
Yes? Someone saying something? Oh, can you please explain again for the binary? Yes, I'll explain it again. Okay. Okay, let me go.
It is a bit confusing.
Yeah, it is a bit confusing. Okay, so here's what's happening. Look, there's 8 bits. Okay, there's 8 bits, and
8 boxes.
Yeah, so then we have an IP address. Okay, this is an IP address. I know it is a bit confusing. It did take me a lot of time to memorize, understand myself. So we got, now each of these 4 bits, each of these 4 octets have 8 bits inside them. Okay, so there's 8 bits, and these are classified as octets. Okay, so there are 4 octets, and each of them have 8 bits. Okay, now 8 times 4 equals to 32. So that means there are 32 bits in an IP address, in an IPv4 address specifically. Okay, so yep, we got 32 bits in an IPv4. I might be speaking a bit fast, which is why I'm speaking a bit slow, because I do tend to speak fast. And we got 32 bits in an IP address, and each octet they have, there is 8 bits. Okay, and obviously I've told you guys the ranges. So right now, what we're doing right now is we're converting it into binary. Now, binary is how computers process data, which is why we're using zeros and ones. Hopefully this clears it out a bit. Can you message me again? I'm not gonna say who, but if you can, if you understand it. Yeah. Okay. Now, guys, it's like 8 digits. Let's say 1, 2, 3, 4, 5, 6. It's X because it can be ones and zeros. Okay. And I want to repeat this again so you guys understand. Okay. Oh, okay. So you guys do understand. I just got a message. Okay. So let's do this again. We got 192. I'm gonna put a 1, and then I'm gonna put 0 because I'm turning 2 network portions on to. Then we put the rest of 0. It's basically addition. That's all you're doing to turn it into binary. Okay, and then I'm gonna write that in 1 1 3 4 5 6 7 8. Okay, I forgot the other one. Oh, okay. For the other one, it was you turn the third one on, and then you put the zeros in between. By the way, do not forget to put the other zeros in between, because that's how you convert it into binary. Normally when we do addition and subtraction and everything, zeros do not count, but for binary they do count, because that's what the computer understands. We got 0 0 1. By the way, I've just done 192. I've done this octet. I've converted it into binary, and now I'm converting this octet into binary. Okay, so we got 0 0 1, and then 0 0 0 0.
First put a dot.
Oh yeah, I forgot to put the dot. Hold on.
So we separated by a dot.
Yeah, separated by the dot, and then we got 0 0 1 2 3 4 5 6 7 8. Okay, now let's do the next one. I am doing it slowly so you guys understand, because I don't want to do it too fast. Okay, we got 192, we got 32. What about 16? So we're gonna go 0 0 0 1 0 0 0 0. That's our third octet. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Let me go on the door. And then, okay. Now for 5, I'll explain how you guys could do this, okay? So I'm gonna do 0 for this, because obviously 5 cannot go into 128, nor it can go to 64 and 32.
So the ones that are bigger than 5, you put zeros in them.
Now 4 plus 1 can equal to 5, right? So I'm just gonna put 1 on 4 and 1 on 1. 1 on 1, yeah. And then 0 on 2, and then I'm gonna write that out. 0, 0, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 0, 1. I have successfully converted an IP address into binary. Now, can you guys please tell me in the chat if I should like repeat this one more time or anything else?
We are going to be doing another example after this too.
Yeah, Aizah will be doing it on we were going to do
On the
the
next
opposite
slide.
example. But the example is going to be a bit different. If you guys want, we can do this and like we can do another example, or we can just skip this example and we can go to this. We're gonna be converting an IP address into binary.
If you didn't understand what Aisha just explained, please tell us right now, because you won't understand the game then. So
The game's simple. It's a little bit more easier. Don't worry.
just tell us in the chat if you understood it or not, and if you need a clearance,
Clearance?
whatever the word is.
Please explain. Okay. I'll explain it one more time.
Yeah, I'll do the other example.
You can do this example. As move.
Not this one.
Here. You can do this.
Okay, so right now I'll try explaining it. So over here we have, this is our binary, right? So this is our binary, okay? And we want to turn, this is our so we need to turn this into a binary format that Aisha showed you before. Yeah, this is our IP address. I lost my English before. This is our IP address. We need to turn this into a binary, okay? So the computer can understand. So when we let's first do 134, okay? First we do 128, okay? 128 plus 128 plus what equals to 134. So this is 128 4, which equals to 132, then plus 2. So 128 plus 4 plus 2 equals to 134, okay? So the rest we add zeros. We don't need to do anything with the rest of them. And look, just like that, we already turned 134 into the binary, okay? So we already turned the first one into a binary. It's that simple. You do it step by step. You take the first one, turn that into a binary, and then you already did the first step. Now you're gonna do, so let me just write this here. So 1 0 0 0 0 1 1 0. That's our first one, right? So we did our first one. So
Alright.
wait, that's good. So we did our first one. Now we have to do our the next part of it.
Next octet.
Yeah, the next octet. So now we have to do 12. So it can't be, we can't do it 128.
It's gonna be A important.
Yeah. 0 0 0 8. So 8 plus what would equal to 12? It's just simple math. Like that. So just like that, you keep on going and you'll get the full thing.
Then we'll get 0 0 0 1 1 0 0. My handwriting is a bit bad on the computer. And then we'll get 64, and then we'll do the same thing. 0, and then I know what it is. It's 0 1.
And then
3, 4, 5, 6, 7, 8. And for the last one, put these two on. This one's gonna be 0, and then 0, 2, 3, 4, 5, 6,
and then 1 1.
Yeah, 1 1.
There, you just completed it. It's quite that simple, okay? Everyone got it?
Let me just ask if they understand.
So now tell us if you understand it or not.
Guys, oh, good.
I knew everyone would understand when my voice arose. Totally.
That is not true. Okay, I want to do this example. Anyways, now let's look at what is the IP address of, we have the binary, and then we're going to convert it into an IP address. Now, this is pretty simple. We just copy whatever it's written over here. You got 1, 1, 0, 0, 0. So
This is the opposite now.
yeah, it's the same thing. I want to do it a bit quickly because I know you guys are getting tired. So, okay, we got 1, 0. That basically means 28 because that's what we got. 128. Okay, so hopefully you guys understand that. And then we got 0, 1. I'm going to delete this. I'm doing it a bit faster now. Okay, then we got 0, 1, 0, 1, 1. Oh, hold on. 0, 1, 0, 1, 1.
So you just
1,
write it down
0.
and then you see
Yeah.
and then you add it up yourself. Then you're just doing the opposite. Now you're turning it from a binary into the IP address. So write it down and then do the math, you'll get it.
76. Okay, and then what else do we have? Last one 0. Which one's on? 4. 0, 0, 0, 1, 16. Okay, 16. Last 4. 1, 2, 3. 1, 2, 3. 13. I hope that's correct. Okay, so that's how you convert it. But you just do the same thing, but like you just write the number, you just write the binary over in like the table instead. By the way, for like doing questions like this, you guys could just like take a paper and like practice and like just write 128, 64, 32, 16, 8, 4, 2, 1. And if you guys didn't know, it's actually the multiplication of 2. It's just 2 to the power of 2. Like, that makes sense. Like 2 to the power of 2, 2 to the power of 2, and then so on. Now you guys do this one. You guys do one by yourself and then we'll play the game because I think it's taking way too long.
Yeah, so we need to like see if you guys can understand it. So try this one for yourself. Probably get a piece of paper if you need one, or yeah.
Oh, I'm so sorry. I forgot to put, yeah, it's actually 92, my bad. Can you guys do this one? And then I'm gonna put the game up. And then I'm gonna make some certificates, like whoever wins, there's gonna be first place and second place.
Whoever wins a game, first place and second place,
They'll
gets a certificate.
You're not gonna get any chocolate or anything, but that's what we provide. If I did have chocolate, I would have eaten it myself, if I'm being honest.
What we answer?
Okay, I will wait 5 minutes and you guys can reply privately or on public, yeah. Let me see the chat. Oh, okay, you guys got it correct. Now let's move on to the game. There was another question, but it's taking way too long. Now we're gonna play the binary game. I'm just gonna take you guys through this. I'm just gonna open the screen. I'm gonna give you guys the link right now.
Okay, guys. It's about time I took the stage. Okay. Okay, guys. So we're gonna be playing the binary game. So first, everyone pay attention on this screen. We're gonna first go through the instructions. There's an instructions option. I'm gonna show you guys. So in this game, you guys will be doing the puzzles in two types: the binary game, the binary puzzles and the decimal puzzles. So let's look at the binary puzzles first. So in the binary puzzles, I'll actually show you like this. It's gonna be easier for me. Yeah, back to menu. Yeah. Okay, so how we're gonna play this first? So you guys won't be having a whole IP address like we showed you guys in the example. You guys will have only one number, and in that one number you guys just put it. See, this is wrong. The yellow is wrong. You have to fix it. Look, this is 1, right?
We're basically doing conversion in a game.
And in 34, look, this has nothing to do with 34. So you guys have the numbers underneath and on top. 32 plus 2 equals to 34. 128 is right here, so 128. So for the green ones, you have to write what is. So on top, this is 8. So I'm gonna write 8. This one here is 4. So I'll just put 4. It's pretty simple, and there will be levels. On the right side, you can see your score. Right now, you guys will be on level 1 when you start. Then it will show you how many lines you have left until you expand to the next level. So over here, which one's 24? 16 plus 8. Is that good? Yeah. And then
I'm gonna work on the certificates until
Aisha's gonna be making the certificates. I'll just quickly finish this example. And then for 11, 8 plus 2 plus 1, 0. Turn all of it off. If it says 255, just put all of them on. If it says 255, just turn all of them on. So, do you guys understand the game?
Just ask them. Go to the chat.
Guys, can you just tell me if you understand the game, or do you want me to like play a bit more and show you? So green, you write what it is, and yellow, you put what it is on the right side, so you fix it.
Okay. We got so many yeses. There's link. You guys could start playing. And whoever gets first place, guys, when you guys finish, we're gonna put a 5-minute timer right now. So everyone just start playing the game. And whoever gets to the highest level, we're gonna give them first place and second place.
Oh, and if any of you guys manage, and make sure that it doesn't fill to the brim. If all of the questions fill to the top, you lose. Okay? Cool. So make sure you don't let it fill to the top.
Okay, you guys have 6 minutes. Aizah will also be playing. She's gonna start now.
Yeah, so I'm in the competition.
Just to the side. Yeah, there.
Yeah. So just make sure it doesn't reach to the top, or else you lose. Answer it fast.
By the way, guys, if you guys didn't know, I forgot to start the timer. Hold on. I created these slides on Canva, all of them, and it just take a couple of hours to pile up one. But yeah, if you guys were wondering, all of these slides were created by Canva, and they were 62 slides. But we did skip like 10.
Okay. Okay, so I'm on level. Okay, I'm almost at level 2. Let's see if I can beat you guys.
I've had at the background. Wait, thing.
I'm at level 2, guys. Let's see if I can let it not go to the top. This is going to be hard. This is intense. Like the quietness. Two minutes left, guys. 2 minutes left. One minute left. 1 minute. Let's see who wins. I'm actually so excited to see the winner. It's getting harder. Oh, and just so you know, when you reach up to level 4, the help guidelines, the numbers on top will disappear. So if you manage to reach up to level 4, you won't have the numbers to help you. Okay, everyone, time's up. Everyone, please stop the game.
Just press end game.
Just press end game
Oh,
and don't cross out the tab. Tell us what level you reached up to.
You can see before you end the game, there's like a score on the side.
Don't end the game right now. First, see what level you're up to, and then share it on chat.
Aizah went on level 3.
Truthfully, share it on chat.
Yep. Do not change it or anything.
Okay. Everyone, tell, and then we'll decide who's the winner.
Ooh.
Till score is on the top right, but we're looking at the level.
Yeah, we're just looking at the level. But guys, stop playing from now, yeah, right? Just I don't know.
I think I already found the first place. I haven't seen anyone beat this person yet.
But you're not gonna see the person right now, right, Aizah?
Yes, I'm not.
Sorry, do not wait for my comment because I was not able to play this.
Okay,
okay.
Sorry for that.
Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay,
Why does it leave it here? Let me just look. Oh, okay. Okay, let me leave it. We'll tell you the results in 2 minutes.
okay, guys.
Wait, okay, hold on. Before we leave,
Okay.
I'm gonna just go back to the presentation, but I'm gonna hide it.
We're just. So, the person who got first place is actually my cousin too.
But we're not gonna name who it is yet.
We're not gonna tell, but he's my cousin. Okay, drum roll.
We're gonna go from second. Now, many of you guys did get many of you guys did get level 3. Did go into level 3. So these are the people that got level 3.
Misham, Alaya, Asad, Kashif, and Junaid Uncle. So guys, good job for getting
Second. All of you guys tied. All of you guys tied.
Oh yeah. We're getting second place, and Yeah. Okay. First place. The person who got first place is our cousin, Asher. Boy. He got first place. Good job.
He went to level 4 and the other contestants went to level 3 max.
Yeah. So level 4 must have been hard because you have no numbers as guidelines. Okay, guys. So well
We
done.
didn't count the people who got level 1 and level 2. Some of you guys did message me. That's because we only tied it between level 3 and level 4.
Good job for the winning contestants. Yeah.
Thank you guys. What's the prize?
The prize is a certificate, you see, and you're gonna get digital chocolates.
Digital.
Yeah, that's what we're doing. Trust me, if we could give prizes online, I would. But like, I don't know how to give you a prize.
She doesn't even know how to give chocolate. She'd eat it.
Be quiet, okay? That's
You
not.
said yourself.
Yeah, shush.
What about level 0? I'm at level 0.
Level
You
0?
get the biggest prize. You get first place.
Okay. From the bottom at least.
Yeah. Anyways, thank you so much for everyone for joining. Thank you for Aviz uncle Chachu, for us to Chachu. You guys might call it uncle. Thank you so much for joining. Thank you everyone for joining. It really means a lot. And thank you so much for Sir Tiaz for joining and staying with us for the whole webinar. And it is a bit crazy because we've got a couple of people from different countries. And thank you so much for bearing with us and everything else. And I'm going to send a form to you guys. If you guys don't mind, can you guys fill in this form? I will wait a couple of minutes.
Yeah,
Hold on.
thank you guys so much for attending this webinar. And it was so great to have you guys.
Now let's wrap this up. This brings us to the end of our presentation. Now once again, I would want to thank everyone for attending, especially our seniors. I know you guys might have not got anything from this webinar, but thank you so much for motivating us, encouraging us by joining anyways. Me and Aizah, in the end of the day, are still average students, so do keep that in mind. And we still need improvement, and we still need some recommendations of how we can improve. Because obviously, we are giving a webinar, but we don't really know how or what mistakes we have created. So if you guys have any tips that you guys could give us, can you please give it in the form I'm going to give you on the Zoom chat? And also, for the people who are watching the webinar pre-recorded, I am going to add the form on the description of the YouTube video. I am editing this right now, so here were the comments. I did copy everything into Notepad because there was an option. So here are the comments that some people gave, and there are more comments, but I couldn't fit it in one screen. But thank you all so much. And for privacy reasons, I have blurred the names. And thank you to all the people who submitted the form. And I did get lots of different feedback and different opinions, such as some people said to me that I added too much content. Some people said that maybe I was speaking a bit too fast. Some people said that I was speaking a bit slow. So one person said that. So there were different concepts and different perspectives. And I do appreciate this because I need to improve myself. For anyone wondering, this is my LinkedIn profile, and I do not have that many connections. I only have 25 connections, and I am hoping to get more connections. So if you guys could add me, that would be really helpful because I'm really trying to expand my network. I will add this and the form in the description of this YouTube video down below, so do not worry. For those of you wondering, this is my YouTube channel, and in this YouTube channel I upload different types of content. I upload technology content, I upload art content, I upload traveling content, food content. It's a bit of a mixed variety of different contents that I upload, and you can find different playlists of mine. For example, if you go to my channel and go to the playlist section, you can see the different playlists that I have, and I am thinking to make a separate channel that's only for technology. So do write down in the comments down below if you guys have watched this video. I will know because you guys will be answering this question if I should do this or not. Don't forget to smash that subscribe button. If you've made it to the end of this video, I would like to thank you so much for watching this. Don't forget to like, subscribe, and share. Bye bye.